Good afternoon, everybody. Myself, Chakradhar Ruprao Mathankar, Assistant Teacher Ratnibai Vidyalaya Wardha. RMSA राष्ट्रीय माध्यमिक शिक्षा अभियान and IIT Bombay presents the Quality Improvement in Math Education project, in which I plays the role of Master Trainer. My registration number is C084. School name is Ratnibai Vidyalaya Wardha. Topic of presentation is triangle and congruence of triangles. Our guide teachers are I.K. Rana, IIT Bombay, and S.G. Dharpure, IIT Bombay. My topic is triangle and congruence of triangle. First of all, I will introduce you a geometry. Geometry is the study of mathematics which deals with measurements, analysis and conclusions of geometrical figures like line, angle, triangle, quadrilateral, etc. In this chapter, we will study the triangle and congruence of triangle. Parts. First, observe and explore. Second, define and prove. Third, apply and evaluate. By observing, you will see that there is a circle, triangle, angle, hexagonal, then rectangle, etc. These are the different shapes, different sizes, geometrical figures. Now, observe these figures. You see that there are pairs of figures. If we observe the shape and sizes, you see that there is a same shape but different sizes. In first figure, there is a figures in which the triangles and inside the circles, then circles, triangles and quadrilaterals. Now, next you observe the next figure. Again, in these figures there are some pairs of geometrical figures. Observe the shape and size. By observing them, it says that the figures have same shape and same size. Next. So, by observing this figure, we can ask the questions to the students that what do you observe in above figures and what is your conclusion from the above figure. Second part of this presentation is define and prove. Now, triangle. Now, how we will define triangle? When the 3 points are collinear and if we draw a line passing or segment passing through these 3 distinct points which are collinear, then we will get a segment only. But if these 3 distinct points are non-collinear and if we join them to each other by a segment, then we got a figure and that will be a triangle. Therefore, we can define this triangle as follows. A closed figure obtained by joining 3 non-collinear points is called a triangle. Now, we can observe this triangle and can tell the elements of this triangle. Triangle has 3 types of elements. First, vertices, second, sides and third, angles. Now, what is vertex? We know that the point of intersection of the 2 segments form an angle is nothing but the vertex. Therefore, in this triangle we see that there are 3 vertices. Therefore, every triangle has a 3 vertices. Second type of element is side. Side is the segment joining the 2 vertices of triangle. And if we observe how many sides to the triangle, then it sees that there are 3 sides of a triangle. So, triangle has 3 sides. Third is angle. We know that the angle is nothing but the union of 2 rays having common origin. So, here also there are the union of segments having common origin. If we observe the angles, there are three angles on the triangle, and therefore in this way, in triangle ABC, if we observe the vertices, sides and angles, it sees that point A, B and C are the vertices, segment AB, segment BC, segment AC are the sides, and angle A, angle B and angle C are the angles of it. We will see that the properties and types of triangle. First, properties. We know that first important property of triangle regarding the angles is sum of the angles of a triangle is always 180 degree. Second, if we produced any segment of a triangle, then at the vertex the angle is formed exterior to the triangle, and that angle is called as exterior angle. We can produce two segments at the same vertex. Therefore, if all sides are produced through the vertex, each vertex, then we get the two exterior angles at each vertex, and therefore every triangle has three exterior angles. The property regarding the exterior angle, the measure of the exterior angle is always equal to the sum of its remote interior angles. In figure, we see that Z is the exterior angle, measure of the exterior angle, X and Y are the remote interior angles. Therefore, exterior angle Z is equal to remote interior angles, their sum is X plus Y. The three main types of triangle. First is a right angle triangle. How we will define this right angle triangle? The triangle having one of the angle is right angle is called right angle triangle. Second, isosceles triangle. When the two sides of any triangles are congruent to each other, then that triangle is the isosceles triangle. Third one is equilateral triangle. Equilateral means all equal. So when all sides of a triangle are equal or congruent, then that triangle is called equilateral triangle, and automatically the property will be created that all angles of equilateral triangle will be same. Second, in isosceles triangles also, the two angles will be always congruent to each other, which are opposite to the congruent sides. The congruent triangles. When the two figures are congruent, initially we have seen that in observed and explored, there are some figures in each pair which we have shown that the figures of same size and shapes. Now, when we define the congruent triangles, we should know that 1-1 correspondence between the vertices of two triangles. We can take the 6 types of 1-1 correspondence between the vertices of two triangles. Out of them, if we take one of the correspondence, 1-1 correspondence, then we can define the congruent triangles as follows. Two triangles are said to be congruent to each other if for 1-1 correspondence between the vertices of two triangles, all sides and angles of one triangle are respectively congruent to corresponding sides and angles of the other triangle. In figure, it says that there are two triangles, PQR and LMN. In triangle PQR and triangle LMN, for correspondence PQR corresponding to LMN, if the side PQ congruent to side LM, side QR congruent to side MN, side PR congruent to side LN, then and angle P congruent to angle L, angle Q congruent to angle M, and angle R congruent to angle N, then automatically the triangle PQR will be exactly overlapped to the triangle LMN, and then we can say that the two triangles PQR is congruent to triangle LMN. Now, criteria for congruence of triangles. Now, when two triangles are congruent, we had seen that if the all six elements of one triangle are congruent to the corresponding elements of the other triangle, then the two triangles are congruent. But in order to prove that the two triangles are to be congruent, it is not necessary to show all the six elements of first triangles are congruent to corresponding elements of the second triangle, but suitable pairs of three elements of one triangle should be congruent to the corresponding elements of the other triangle. In order to prove whether the two triangles are congruent or not, we need to know that all the six parts of one triangle are equal to the corresponding parts of the other triangle. But it is possible to prove the two triangles to be congruent if we are able to know the equality of three of their corresponding parts. For example, if we construct a triangle ABC and if we construct a triangle PQR such that AB equal to PQ, BC equal to QR and angle B equal to angle Q, then automatically these two triangles will be overlap exactly, and if the two triangles are overlapping exactly, then we will say that the triangle ABC is congruent to triangle PQR. Here only three pairs, congruent pairs are necessary to show the two triangles to be congruent. Test for congruent triangles. Test means it is nothing but the group of three pairs, three corresponding congruent pairs of the triangles. In figure you see that there are two pairs of side, two pairs corresponding included angles are congruent. So this type of triangle, then the triangles are automatically congruent to each other. That test is called as a S test. In second case, we see that there are two angles of a one triangle are congruent to the corresponding angles of the other triangles and their included sides are congruent. Then this test is called ASA test or AAS test. Then third, if all three sides of one triangle are congruent to corresponding sides of the other triangle, then the two triangles are congruent to each other. That is SSS test. Fourth, in right angle triangle, if the hypotenuse of one triangle is congruent to hypotenuse of other right angle triangle and any perpendicular side of one triangle is congruent to the corresponding side of the other triangle, then the two right angle triangles are congruent to each other. Then we will see one theorem. The statement of theorem is the angles opposite to the equal sides of a triangle are equal, given that in triangle ABC, side AB and side AC are congruent to each other. To prove angle B is congruent to angle C. Now here it is necessary to construct the bisector of angle BAC. We will construct a bisector of angle BAC which will intersect the side BD at a point D, so that BDC are collinear to each other. Now prove in triangle ABD and triangle ACD, AB congruent to AC because given, angle BAD congruent to angle CAD because construction, AD is equal to AD because common, and therefore triangle ABD congruent to triangle ACD by SAS test, and therefore by corresponding angles of congruent triangle, this property, the angle B will be congruent to angle C. Now we will see that the next theorem is converse of the theorem number 1, that sides opposite to the equal angles of a triangle are equal. Given that in triangle ABC, angle B and angle C are congruent, we have to prove that side AB and side AC, which are opposite to the angle C and B respectively, will be congruent. Now here also it is necessary to construct the bisector of angle BAC, and this bisector intersect the side BC at point D so that BDC are collinear to each other. Now here angle B and angle C are congruent to each other because given angle BAD and angle CAD are also congruent because by construction, because AD is the angle bisector and AD is congruent to AD because common side, and therefore by SAA test triangle ABD congruent to triangle ACD, and by the property corresponding sides of congruent triangles, the side AB congruent to side AC in this way. Now by using the definitions, properties and the theorems, we can apply the theorems, we can apply the properties or definition, and by applying these things we can evaluate, we can solve some problems. We will see first problem, that the example is in figure PX and QY are perpendicular to the segment PQ. PX and QY are equal, show that AX equal to AY. Now in this figure, in triangle PX and triangle QAY, angle XPA and angle YQA are congruent to each other because each angle is of 90 degree. Angle PAX and angle QAY are also congruent because vertically opposite angles. Segment PX and QY are congruent because given, and therefore that by AAS test the triangle PAX congruent to triangle QAY, and therefore by property corresponding sides of congruent triangles, the side AX and side AY are congruent to each other. Second example, triangle ABC is an isosceles triangle in which AB is equal to AC. If BD is perpendicular to AC and C is perpendicular to AB, then prove that BD is equal to CB. Now we will solve this problem. In triangle BDC and CEB, angle BDC is congruent to CEB because each angle is right angle. Angle DCB is equal to angle EBC because angle opposite to equal sides, and BC congruent to CB because common side, and therefore triangle BDC congruent to triangle CEB by AAS test, and hence BD is equal to CE by the property corresponding sides of congruent triangles. Example number 3. In triangle ABC, AB is equal to AC and angle DAC is equal to 124 degree. Here BAD are collinear to each other. Then find the angles of a triangle. Solution. We know that angle BAC is equal to 180 degree minus 124 degree because angle BAC and angle DAC are linear angles, and therefore their subtraction will be 56 degree, and therefore angle BAC is angle B and angle C, these are the congruent angles because the theorem angles opposite to the equal sides of a triangle. Therefore sum of these two angles will be the double of one of them, that is twice B is equal to 124 degree, and therefore the angle B is equal to half of it, that is 62 degree, and therefore angle B and angle C each will be 62 degree. Then at the last we can take some problems for practice. In this way we can give the examples for practice to the student.